Hi everyone, I'm Nick. I was previously a science teacher for 10 years before I joined Interactive Scientific, and now I create their classroom resources to help you to get NanoSymbox into your classroom. This is our session on respiration. All of our lessons are made so that they can be as out of the box as possible. So they come with a worksheet. You'll notice on the PowerPoint it says, fill this in on your worksheet, write this down on your worksheet. This is the worksheet that we're referring to. So it starts off with a settler activity, just to get them thinking, get them engaged. And then we go into a bit of a game show mode. This is where you're testing their previous knowledge and looking out for any misconceptions that they may have. So they write down a fact about respiration on their whiteboard. You go through the misconceptions. And then you go through what they do know. Obviously, if your class are mostly getting these right, then that's a good base point to know where they are at the beginning of the session. Then we've got the learning outcomes and the learning objectives. You may need to change these depending on what the rules are in your school. It's entirely up to you, or depending on the ability of your class. So we go through a quick recap on animal cells. This is to check whether or not they've come across mitochondria before. They mostly should have done, but just in case they haven't, this is where it gets introduced. Then we talk through what is respiration. This is a fill in the blanks, basically to save them a bit of time because the lesson's got quite a lot of different elements in it. But it means that they've still got the sentence written down. Then we have a nice little interesting fact for them. So then we start to introduce how can you write these sorts of processes in a shorter version. So we start to introduce word equations. So they know that these are the things that are involved and these are the things that are produced by the mitochondria. And this is a nice short version of writing down everything that happens in respiration. Now, the next thing I do is I introduce the chemical equation. And so to do that, we introduce the the elements and molecules. I think it's important that students understand chemical equations because it just gives them a whole different angle to access the learning from. Some students work better in numerate ways, and chemical equations are much more easily accessible for more numerate students. So this is where we introduce NanoSymbox. So they collect a tablet or a phone. It works really well on phones. So if, of course, you don't have access to the tablets, then they can use this on their phones. You will have entered in the code and you will have entered in where they can find these molecules. And what they do is they work through building up the different molecules and they write down the chemical formula for each of them. So when I introduce balancing chemical equations, I always like to tell them that it's a bit like a cake. So they know that when you make a cake, you put all the different ingredients in, and then you mix it all together, you bake it, and it comes out and it's completely different. You can't separate out those ingredients very easily anymore. But then you can emphasize the balancing bit, that there's still the 2 eggs and the 200 grams of flour and things like that. They just are arranged in a completely different way. So you have to make sure that whatever has gone into it is the same as what's come out. So firstly, these are the symbols that they will have got from using NanoSymbox. Point out why we're not including energy, and we're pointing out that oxygen goes around in pairs unless it's attached to something else. And then we have to point out that actually this isn't balanced. So when I go through balancing equations, I like to use this counter method. So there's 6 counters for carbons, etc. So that they can really see it in numbers. So we talk about the fact that we need to put 6 more carbons to balance it on both sides, but we also need to discuss that you can't just multiply the carbons, you actually end up multiplying the whole molecule, and that's something that they need to bear in mind. So they go on through and they keep going until they end up with a nicely balanced equation. What I think is quite useful as well about knowing the chemical equations is that they mostly know that oxygen is O2, they know that carbon dioxide is CO2, they know water is H2O. And from knowing those, they can work out glucose. And actually, in most exams, you can get away with writing the symbol equation. If you can't remember the word equation, you will at least get some marks for it, unless it's a specific word equation question. So again, they write it on their worksheet. And then, of course, because it's a respiration lesson, we have to show them the screaming jelly baby. Just to point out that there are obviously some risks associated with this lesson, and I have included some of the general risk assessments, but you will need to do your own, especially depending on your school policy. So then we have a little circus of practicals. This is basically because the best way to learn about respiration is by doing the practicals and seeing it for themselves. So we warn them about the safety, what they need to do. They should all know this, but they always need reminding. So there's 4 practicals around the room, and they've got space on their worksheet where they write down what happened and what they think that means. So they blow into the lime water, they breathe on a mirror. I've not included using cobalt chloride paper, but you can do if you choose to. Obviously that's an extra risk assessment because they're not supposed to come in contact with that. A balloon on a boiling tube of live yeast. And then finally the elastic band finger exercise. If you don't know what this is, this involves them putting an elastic band in a figure of 8 around their thumb and their third finger, their ring finger. And what they do is they stretch out and contract their hand as many times as they can in 2 minutes, or as many times as they can until they can't do it anymore. And that's a really, really good way of introducing anaerobic respiration. So that's where you start to introduce that aspect of it. So then we go back to Nana's inbox and they have a look at lactic acid. And we get them to write a balanced symbol equation for anaerobic respiration. So we give them the word equation and we get them to write down a balanced symbol equation. Obviously, it's not as difficult as it sounds, and they will find that when they find their 2 molecules and write them next to each other. Then we have the plenary. So how would you test for factors affecting the rate of respiration in yeast? What factors could you change? So this is basically testing whether or not they have taken on board the reactants and the products involved. So obviously they want to be able to change the reactants and they want to be able to measure the products, and that's what you're looking for. There is also an extension of how would you teach this to someone else in a fun way. I always like to do this because obviously students can be so incredibly creative that it's always quite interesting to see what they can come up with. If you've got any questions, feel free to give us an email at info@interactivescientific.com. I hope you enjoy teaching the lesson.